Okay, we're going to do a little review of some of the topics that are giving you kids the most problems right now. So we'll start with greatest common factor. For example, if you were going to find the greatest common factor of, say, 20 and 36, remember the easiest way I taught you is to first write that 20 and 36 as if you were simplifying a fraction. And you would want to divide by 2, 3, 5, or 7, or any other common factor that pops into your head that you may know of. Since they're both even, a lot of kids like to start with 2. So we'll divide them both by 2. We cut 20 in half and get 10. Cut 36 in half and we get 18. And then you look at it again and say, okay, they're still even. I can still simplify. So now we're going to divide 10 and 18 by 2 again, and you get 5/9. Now 5/9 is in simplest form. Now we have divided 20 and 36 by 2, and then we divide it by 2 again. So we find the product of those two common factors. When we put them together, we get the greatest common factor. So the greatest common factor of 20 and 36 is 4. The next topic we're having some trouble with is least common multiple. Least common multiple, we have to remember that we're using multiples as in skip counting. If you were to try to find the least common multiple of, say, 5 and 15, remember the easiest way is to always circle the bigger number, since it's a multiple of itself, and then check to see if the smaller number divides evenly into it. So 15 is a multiple of 5, and 15 is a multiple of itself, so 15 is the least common multiple. Let's do another example that doesn't work out quite so easily of, say, 4 and 7. Do it the same way. Circle the bigger number, and then we want to skip count by 7, and by skip counting by 7 we're listing multiples of 7 until we get a multiple of that's also a multiple of 4. So 7's a multiple of itself, and I'll just list them down here. So we have 7, 14, that's not a multiple of 4, 21 is not a multiple of 4, then we get to 28. 28 is a multiple of 4, so 28 is our least common multiple. The next topic we are struggling with is prime factorization. And remember, it's nice to write your prime factors when you're done as exponents. So we'll start off with one. We're just going to do one example. We're going to start off with 60. You want to start off by just putting down any two factors that make 60. Easy place to start is 10 times 6. You may have been thinking of 12 times 5. That would have also worked. So we'll do it two different ways just for fun. So I'll write 12 times 5 here. And we'll kind of do it both ways and see that we'll get the same answer no matter how we do it. Now 10 is not prime, so we still have to factor the 10. So some factors of 10 are 2 and 5. Remember, 2 is prime, so we circle it. 5 is prime, we circle it. Now we're going to factor the 6, since it isn't prime. 2 times 3 makes 6. They're both prime, and now that they're all circled, we don't factor them any further. So the prime factorization of 60, there are two 2's, so we're going to write 2 squared times 3 times 5. So there's your prime factorization of 60. 2 squared times 3 times 5. Because 2 times 2 is 4, 4 times 3 is 12, and 12 times 5 is 60. Let's go over here. Now we see that 5 is prime, so we'll circle it, but we still have to factor our 12. Okay? 3 times 4 is 12. 3 is prime, we circle it, and we still have to factor the 4. 2 times 2 is prime. 2 times 2 is 4. I apologize. And the 2's are prime. 4 was not prime. That's why we still had to factor it. So to list our prime factorization of 60 over here, we have two 2's again. 2 squared times 3 times 5. Either way, it works out the same. Now we're just going to do a couple examples with decimals. Some decimal review. Remember, if you're adding decimals, you must line up your decimals, even if you're adding something like a whole number and a decimal. If you're adding 15 plus 4.7, you can do this easy enough in your head by just counting the 4 ones onto 15, makes 19.7, or if you'd like to write it out, you would have to write 15.0 plus 4.7. Notice that I've lined up my decimals. Drop your decimal straight down, 19.7. Likewise with subtraction of decimals, if I were to do 33 minus 4.6, we would have to line up our decimals. So we're going to have to make 33 into a decimal by making it 33.0 minus 4.6. We can't take 6 from 0, so we're going to borrow from the 3, make it a 2, and make the 0 a 10. Now 10 minus 6 is 4. We can't take 4 from 2, so we're going to borrow from the 3, make it a 2, and make this 2 a 12. 12 minus 4 is 8, and 2 minus nothing is 2. 28.4. Just remember to line up your decimals. Multiplying decimals. Some of us have problems when we're multiplying decimals because we'll think that we still have to line up decimal places, where you don't have to do that with multiplication. You just count your decimal places. So if we're multiplying 15.7 times 2.6, remember to always put your shortest and easiest number on the bottom. So I'm going to write 15.7 on the top and the 2.6 on the bottom. Now I'm going to multiply 6 times 15.7. 6 times 7 is 42. 6 times 5 is 30. Plus 4 is 34. Now 6 times 1 is 6. Plus 3 is 9. I'm going to cross out what I regrouped, and I'm going to cross out my 6 since I already multiplied by it. I have to put a placeholding 0 under the 6, because since I'm multiplying by 2, I need to start underneath the 2 now. 2 times 7 is 14. 2 times 5 is 10. Plus 1 is 11. And 2 times 1 is 2. Plus 1 is 3. Now these are called our partial products because 942 is part of the product when we multiplied 15.7 times 6. And this is the other part of the product when we multiplied 15.7 times what looks like a 20. And we really ignore our decimals until last. I know that's 2.6. So we have 2, 8, 10, and 4. And now we count our decimal places to place our decimal at the end. 1, 2 total decimal places. So our product's going to have 2 total decimal places. So the product is 40.82. 2 more examples, and we're going to do 2 examples where we divide decimals. One where we divide a decimal by a whole number. We'll do 3.9 divided by 3, and then we're going to do an example where we divide a decimal by a decimal. Dividing a decimal by a whole number is very simple. You just pop your decimal straight up into your quotient, put your caret above the place where you're going to start dividing. Since 3 divides into 3 once, 1 times 3 is 3. 3 minus 3 is 0. And now drop down your 9. 3 goes into 9 3 times. 3 times 3 is 9, and you have no remainder. Now the other example that we sometimes forget to do correctly is, say we're doing a 4.8 divided by 0.12. Now we want to make the 0.12 into a whole number. So to make that into a whole number, we have to move the decimal 2 places to right, we have to multiply it by 100. If we ever change the divisor, we have to change the dividend the exact same way. So we're going to multiply the dividend by 100. 4.8 times 100 moves the decimal 2 places to the right and turns it into a 480. 0.12 times 100 moves the decimal 2 places to the right and turns it into a 12. Now, just like before, we're going to put a caret above the place we'll divide into first. 12 doesn't go into 4, but it goes into 48. So I put a caret above the 8, so we know now we're going to have a 2-digit quotient. 12 goes into 48 4 times. 12 times 4 is 48. We subtract, get 0. Bring down the next 0. And whenever you bring something down, you must divide into it. 12 goes into 0 0 times. 0 times 12 is 0. And now you could say it's official, there's no remainder. So 4.8 divided by 0.12 is 40. Okay, that's it. Study these and you'll be all caught up.